Hey Techno Studs! One of the critical components to these dynamic routing protocols is the packets, the communication between the routers. So let's take a look at the OSPF packets. When it comes to OSPF, there's quite a few different packet types. So we're going to take a look at the different types of packets. Then we're going to get into specifics of each one. The different packet types are the hello packets, the database packets, the link state request packets, the link state update packets, and the link state acknowledgements. Then we're going to wrap this up by talking about link state advertisements, which is a component of several of these packets. When we say packet types, what we're talking about is the payload here. But we still have to remember the rest of the Ethernet frame. We've got the layer 2 heading and layer 2 trail on it. We got the IP header, and we actually will be taking a look at the OSPF header here. So let's start out by taking a look at the OSPF header, and then we're going to get into what is going to be found in the OSPF load, and that is the different packet types here. The OSPF header looks like this, and just as a refresher, each one of these is a byte. So there's 1, 2, 3, 4 bytes. If you want to count the individual bits, there's 8 bits for each one of those bytes. These are the labels, so this is byte 0 through 3, this is byte 4 through 7, byte 8 through 11, 12 through 15, and so on and so forth. So we can see how this packet is formed and the OSP header. What does the OSPF header look like? Well, first of all, we have the version here. And so OSPF, we're going to be using version 2 for right now. So if we were to switch it to version 3, then we would find a 3 in this top part right here. Then we have the type. The OSPF type defines what the payload is going to be. So if it's the hello packet, then it's going to be a type 1. If it's the database packet, then it's going to be a type 2. If it's a link state request, then a type 3. If it's a link state update, then a type 4. Or if it's a link state acknowledgement, then it's a type 5. So we would find that right in here, whichever one is, well, we'd find in this type field right here. Next, what we have is the packet length, and that is the total length of the packet. And so that can vary quite a bit depending on what kind of payload is in here. And we'll be talking much more about that as we progress through these slides. Then we have the router ID. The router ID is the ID of the router that's advertising and sending out this OSPF packet that's being sent out. Then we have the area ID. As we mentioned, we're not going to get real in-depth into areas right now. This is going to be area 0 for our network. However, this will change as if we had multiple areas, then this would identify the area that it's part of. We have a checksum just to make sure that when it arrives to where it's trying to go, that it's accurate, does the checksum to make sure that nothing has changed. Here we have the authentication type right here, and that is a 0, 1, or 2. 0 meaning that there is no authentication, 1 meaning that there is just a password, 2 meaning that it's the authentication, what's happening in this field right here is much more in depth. They have a key ID, MD5 authentication data length, they have a sequence number, so there's some extra information that falls then into this authentication part right here. And then the size of this payload right here is going to vary quite a bit, once again, depending on what is being carried on this packet. So what are these different packet types? Well, we just looked at the OSPF header in here, and it showed us a type field that defined what is going to be in the payload of this. And we said that is going to be hello, the database description, the link state request, the link state update, and the link state acknowledgement. So what does that look like when it comes to our topology? Well, OSPF keeps track of quite a bit of data. It has a bunch of data on the neighbors that it has. It also has information on all of the links. So it actually goes through and labels each one of these links so that it can track those links. So one of the things that it needs to do is establish this neighborship between two devices. So it will send those hello packets back and forth so it can populate its neighbors table. So let's just use an example. Let's say we're starting up router 3, and router 3 then starts sending hello packets out to R2. R2 starts sending hello packets out to R3, and then their neighbor tables get populated with that information. Then what happens is router 2 is going to send a database packet to this router 3, and the router 3 is going to see all of the information that this router 2 has that has been keeping track of, and router 3 says, well, mine's not populated because we just turned this on, so it's not filled in yet. And so what it's going to do is it's going to send a request to router 2. So it's going to do a link state request and says, I want that information. Can you give me that information? Router 2 will then send a link state update back and say, okay, here is the information that you requested. And then finally, router 3 will send an acknowledgement. So what is a link state advertisement? This link state advertisement is the details of that. So we see these different links. We're going to have a link state advertisement for each one of those links. So that's going to be how, and that's why we also need a link state ID, so it can actually figure out what I'm requesting, what do you have, and what am I requesting for each one of those links that are in there. Here's another diagram that displays that information a little differently, and I think it will help drive home this point. All right, so what we have here is it's showing the Ethernet frame. The Ethernet frame has a header on it, the layer 2 header on here, and I've also included the layer 3 header on here. So that's going to be just the standard layer 2 and layer 3 information that we've already been talking about throughout this whole course. And the layer 2 trailer, same thing right there. But what we have here is the OSPF header. And the OSPF header, the fields are going to remain the same throughout this communication, but the information in the fields will change depending on which router is talking to which router. So that information will change a little bit within those fields, but the fields themselves are all going to be the same fields. All right, so that gives some information as it's passing back and forth between these different devices. Now, we see here we have a hello packet right here. Let me change the, let's do a red, how about that? So we've got a hello, which is a type 1 right here. What does the hello packet look like? Well, it starts out by having some information, and then it will list out all of the neighbors that it has. So, and there could be, I've got to give an example of 5 here. Maybe it just has 2. Maybe it has more than 5. So it will vary in size depending on how many neighbors it needs to list and send with this hello packet. All right, then we have the database packet, which is a type 2. The database packet has information in it that's being passed back and forth, and then it also has a LSA header. So all of the LSA headers, and once again, there'd be a lot of different link state advertisement headers in here, and this passes link state header information from router to router, so the router can see if it needs to get an update to any one of these link states and get information on any one of these link states. Then we have the link state request, which is a type 3, and the link state request has many different requests in it. It's a very simplistic packet, and we'll see that here in a little bit, but it just requests, hey, I would like to get an update to this link state. And then the response to that is a type 4, and it's sequenced, so it'll have some numbers in there, and then the link state advertisements right here will consist of a header and some information. So this is the full link state. So this is really the full link state here. And then the acknowledgement, what's sent back is a type 5. It has some information here, and it will send back the link state advertisements headers back. So just a brief description of each of those link states. If we have two routers that are talking back and forth to each other, the first thing they're going to do is establish an adjacency. And they're going to do that with hello packets. So the hello packets starts out with the network mask. So what is the network? It's going to give the hello interval, which is how often they're going to chat back and forth. How often are they going to send hello packets back and forth? And that acts as what's called a keep alive, just making sure, hey, are you still out there? This is my information. I'm still up. So it's just a reminder, I'm still up, and it's sent out every 10 seconds, every 30 seconds. Then we have some options that we can configure on here. And we also have the priority. What is the priority of the router? And we're going to get into priority in a little bit. It has the router dead interval, which we will get into as well. It's similar to the hello interval right there. And then we have the designated router. And we, as I mentioned, we'll talk more about the designated router and the backup designated router. But essentially, this is just one router telling the other router who it deems as being the designated router and the backup designated router. And we'll get more involved into that in a later video. And then it lists all of the neighbor router IDs. So the RID is the router ID. So if this router 2 is talking to router 1 and sending this information to router 1, then it's giving it all of its neighbors that it sees. So router 1, 2, 3, 4, 5, or maybe it just has a couple, then it would only send a couple over there. So however many neighbors that it has, it will send over. So let's take a look at the database packets. The database packets, first of all, has some information in the first 8 bytes up here. One of the things it has is the interface MTU. This just allows the other router to know what's the maximum amount of data that it can send over to this device without fragmenting the data. So that's the interface MTU. We've got some options that we can set in here. We've got some flags that are in here, and we have a sequence number. And the sequence number is to track which database packets are which database packets. So this is, we don't need to go in great detail about this, just know that those fields are in there. And then it has all of the high-level link state advertisement header that's in here. So things like the link state age, options, types, link state ID. So each of your links is going to get a ID to it. So this is the link state ID, which router is advertising that particular link, the link state sequence number, a checksum, and a length. Okay, once again, I'm not going to go real in depth into all of these, but just know that this is the link state header, and then you would have another link state header down here, and we would have multiple link state headers attached to this. And it's just information about each one of those links, describing those links and giving some detail about those links. The link state request packet here has much more simplistic information. It just really needs to pass over the link state ID and a couple other pieces of information that says, hey, I would like to find out more information about that header. You sent me a header. I don't know the rest of the information, so please give that information to me. In response to that request, a link state update will be sent out, and it will have all of the information for each of the link state advertisements that were requested. So it's the complete link state advertisement. So in it, it includes the header part of this, which is something that we've seen a few times already. And one of the things that is in this is the link state type. And so the link state type will also it will determine what is down here in this payload right here. So the link state advertisement information, this size is going to depend on what type it is. And there's a lot of different types, and we'll discuss some of those types here. But essentially, all of the link state information is being sent over in this link state update. Of course, there can have multiple updates to this. And so since there can be multiple updates, it needs to know how many updates there are. So here we have the number of link state advertisements that are in this update. And we can see the beginning of another one down here. And then that information is acknowledged with a link state acknowledgement. The link state acknowledgement just has the LSA headers of each of the link states that was sent to that router. So here is the link state advertisements by itself. We see quite a bit of information in each one of these advertisements. So each one of these link state advertisements would represent one of the links. And we'd have each one of those links would have a link ID. We've already talked about how I'm calling this top part the header right here. And the header can be found in both the database messages, packets that are sent out, and also in the link state acknowledgements that are sent out. There is a section of the header here, the link state ID, the link state type, and the advertising router. So these three components right here can be found in the link state request. And then all of this link state is found in the link state update. In fact, the link state update can have multiples of these to include whatever information is in here. We've already said the LS type is going to determine what information is down here in this LSA information. So what are the different LSA types? Well, there's a lot of different type of networks out there, and we need to represent what these different type of networks are. And OSPF will treat those different types of networks a little differently. So what do we have? Well, first of all, one is a router LSA, and I'm not going to get into a huge definition, just know that there are different, and depending on which LSA type it is, we'll have different information in there. A type 2 is a network LSA. A type 3 and 4 is a summary LSA. Now, these 3 and 4 are a little different, but for the most part, we're just going to call it summary LSA. We have a 5, which is autonomous system external LSA. We have a 6, which is a multicast OSPF LSA. We have a 7, which is a NSSA external LSA, or NSSA is a not so stubby area. It's interesting how OSPF goes and defines all these different scenarios within there, so it can treat each one of those areas a little differently. And then we have an 8, which is an external attribute LSA for BGP. So there are actually a few others that I've seen out there, but for the most part, this is the high level, what the different LSA types are out there. So really, if I were to sum up this video, I'd really get back to this slide, which we've already looked at. This slide really outlines the whole summary of everything that we talked about, to include the OSPF header right here, which has certain information that's being passed back and forth between two routers. It lets them know, hey, I'm talking to you, and I'm talking this OSPF language, and some details about those routers. And then it gets into the different types. We have a type 1 through 5 with each one of these. And the hello type is information to set up these neighborships, these adjacencies. It's got some information, and then it's got some different neighbors, all the neighbors that's attached to that router. We've got the database type, which has some information like the sequence number, and then it has these LSA headers involved in it. We've got the link state request, where it takes some of the information from those link state headers and says, I want to find out more information about that. And then what is sent back then is a link state update that says, oh, you wanted to find out more information. So here is the information, the full link state advertisement of the link states you requested. And then it gives a number, okay, what is the number of link state advertisements that are going to be in here. And then finally, we have the link state acknowledgement, which has, once again, some information, and then those LSA headers of, hey, I acknowledge I received information about those link states.